All right, in this example, ladies and gentlemen, the main important thing that I wanted to make sure that I come across is, as I mentioned, the steps that I talked to you guys about. The main important thing is identifying the vertex. Now, remember, when we talked about the vertex, is going to be the form of h and k. So in this case, remember h is x opposite of h, right? Well, here I have x plus, so there's no so we got to remember it's always that opposite. So in this case, my h and k is negative 5, 1, right? Remember the form was x opposite of h, right? So since it's that plus 1, that's we have to use that opposite form. So it's going to be negative 5 is our vertex. Now, the main important thing I want you guys to remember, what I was explaining last in that problem, was understanding the parent graph. Over 1, up 1, over 1, up 1, over 2, up 4, 1, 2, 3, 4. If you guys can remember the relationship of this parent graph, this will be very, very helpful because this is the parent graph. Put it away.
Sorry.
Can you just put it away? Put it away.
Me?
Yes. And you. So, the important thing about this parent graph, guys, is understanding this relationship. That here is when a equals 1. In my example, in my graph, is a equal to 1. Yeah, so guess what? The graph is going to look exactly the same. The only difference is I am taking this parent graph and I am just shifting it to its new vertex. Or I am just translating it on the graph. So if you guys remember in geometry class, all you guys did when you guys did like slides, you just moved the shape. But the size and the shape of the graph is not going to change. So, yes, Jamie?
Why is it negative 5?
Because as I mentioned in the class, which you were probably looking on your phone when I went over with it, is remember the standard form is x opposite of h.
Okay.
So x plus 5 we can write as x minus negative 5. So that's why it's the negative 5.
Okay.
So now what we're going to do, you do not have to draw the parent graph every time. Okay? I'm just using it as a teaching tool to see, so you guys can see the easy way of doing this. Because basically all we're doing is I'm going to take this vertex and go over negative 5, 1, 2, 3, 4, 5, and up 1. So I want you guys to see that my vertex has moved from 0, 0 to negative 5, 1. And now, since a is equal to 1, a is exactly the same, just like this one, when over 1, up 1, over 2, up 4, all I'm going to do for here is go over 1, up 1, over 2, up 4. And you do the exact same thing. So I know I'm not the best drawer, but what you guys should see is these graphs is exactly the same. They're not compressed or stretched from one graph to another. It's exactly the same graph. It's just being shifted to where the new vertex is. You guys see that? Yes, George. What one? Oh, right there.
Where did you get 4? Why did you go up 4?
Because if you remember in the notes that I had you guys, when you plug in, like on this parent graph, y equals x squared, xy, 0, 0 squared is 0. 1, 1 squared is 1. 2, 2 squared is 4. Right? So that's basically going over 1, up 1. Over 2, up 4. Why? Because 2 squared is 4. And what I'm just trying to show you, what I'm trying to make you guys understand is when your a is exactly the same, the values of these are going to be going exactly, the graphs are going to be exactly the same.